Good morning, dear students. So, we are going to cover the last module of Basics of Mechanical Engineering, which is mainly the study of manufacturing process. So, what is the importance of manufacturing process? So, you know that every object come in your daily life, if it is a safety pin or a helicopter, a small object to larger objects that we are used for your life is made by a series of manufacturing process. So in this, one of the major manufacturing process is casting, and we are going to have some idea about sand casting. So the objective of today's session is introduction about casting, then classification of casting, then we will discuss different properties required by the molding sand, different parts of sand casting, and what is the molding procedure for a casting. And finally, we will discuss the advantages, disadvantages, and applications of casting. So what do you mean by casting? So already you know the casting is one of the ancient method. So even though in the BC century, years ago, we have used casting for making sculptures and different vessels, etc. So casting is one of the most ancient manufacturing method, and it is the process of producing metallic parts of desired shape and size, and it is by pouring a molten metal into a mold having a cavity of the part to be cast. So suppose you want to manufacture a cylindrical surface. So what you have to do is you have to create a cavity of that cylinder in a mold, and you will be pouring the molten metal from a furnace into that cavity and allow some time to solidify the molten metal, and the resulting solid will be the shape of the cavity, and it is known as the casting. So casting means simply we will be first preparing a mold in which there is a cavity which have the same size and shape of the product what we want. Then we will pour the molten metal, allow it to solidify, and we will take out the product. The place where castings are made are known as foundry. So you might have done some experiments in a basic mechanical workshop in the foundry. So foundry is the place where these castings are made. And for preparing the mold, this cavity, etc., we will be using a pattern which is the same size and shape of the product to be obtained. So molding is the process of making a mold using a pattern, and pattern is the model or replica of the part to be cast. So it will be the exact size and shape of the part to be cast, but different material. So our product will be mostly metals, but the pattern will not be a metal, need not be a metal. Now we will classify casting. So different casting classifications are available. So one of the based on the type of mold. So already we are told we have to first prepare a mold of a cavity of same that of the casting product to be obtained. So based on the mold used, it can be classified into two categories. Expendable molds. So what do you mean by expendable molds? So sand casting comes in this category. So these molds are used for single casting. So we will be using these molds for single casting. Then after that we will break the mold and we will take the product out. So the mold is broken to get the casting out after it's solidified. So if you want to produce a cylinder, we will first get the impression in the mold with the help of a pattern, and we will pour molten metal we will solidify, wait for solidification. So once it is solidified, we will break the mold to get the casting out. And they are usually made of sand, or even we can use plaster of Paris, ceramics, etc. with binders and additives. So these are the expendable molds. So mostly the expendable molds are made of sand. In some case, it can be also made of plaster of Paris, ceramics, etc. Then we have another classic category, that is permanent mold. So permanent mold is the opposite of this one. So we can repeatedly use the mold for several times. So these molds can be used repeatedly. So we don't have to break the mold once it is used. The casting can be easily removed and the mold can be used for the next casting. And these molds are made of metals. So mostly the permanent molds are made of different metals. So this is the major classification of casting based on the type of mold. Then another classification is according to the method used for molding. So we can classify it into 4 categories. First one is the bench molding. So in this, the molding, the entire mold of convenient height. So it can be used only for small castings. So if the casting is very small, we can prepare the mold on a bench. So it is known as bench molding. And if the casting is of medium or large size, we can do the molding in the foundry floor. So it is, second one is known as floor molding. So floor molding, we will be preparing the mold on the foundry floor, and it is used for medium and large sized casting. And if the casting is very large, for example, if we have to cast a large engine cylinder or large pump body, etc., we will be using pit molding. So pit molding is done in the pit dug on the foundry floor. So a pit is dug on the foundry floor, and casting is usually made of 2 parts. The bottom part is known as drag, the upper part is known as cope, and this drag will be inside the pit and the separate cope is rammed above this, and it is used for extremely large casting. So pit molding, we will be creating a pit to fit the drag, and the cope is placed above that. And finally, we have one more category, that is machine molding. So machine molding, if we are using the help from different machines for operations like ramming, rolling the mold, withdrawing, etc., we call it as machine molding. And machines perform operations much faster and efficiently, and generally they are used for mass production. Suppose we want to produce an engine component or something like that in a large number, use less time and you can produce more efficiently. So it is mainly used for mass production only. And what are the different types of patterns used? Already we have discussed, pattern is a replica of the product to be cast, which is used for making the impression of casting in the mold. So normally wood is the common material used for pattern making. The advantage of wood is it is very easy to work and it is very available. In very cheap price we can make the wood pattern. But the main disadvantage is it changes size due to the effect of moisture in the molding sand. So the moisture will affect the size of the pattern. And also another disadvantage is the wood will wear out quickly. So it can be only used when the number of castings are few. So if we are to produce a large number of casting, this wood will not be preferred because it wear out easily. And metallic patterns are used when there are a large number of castings are to be produced. Metallic patterns are more durable and produce a good dimensional accuracy and better surface finish. So compared to wood, The metal has some advantage, more durable, wear will be very less, and it should have good dimension accuracy and better surface finish. Common metals used for this purpose are cast iron, brass, aluminum, etc. And we can also use plastics. So most of the modern castings use plastics as pattern, and they do not absorb moisture. They are very strong and dimensionally stable, resistant to wear, and they are very smooth surface, and the advantage is they will be light in weight. So if you are used, you can see the most of the advantage of metals are come in the plastics also, but this is an additional advantage. If you are using plastics for making pattern, it will be very light in weight, but if you are using metal, it will be very heavy and it is not easy to work with. So these are some common materials used for pattern making. And we can even use plaster of Paris, wax, etc. for using the some case as pattern material. Now we have to deeply study more about sand casting. So this is the figure of sand casting, and this is the pattern used for producing cylindrical shape. So in sand casting, the basic mold material will be sand, and we are adding some binders and additives also. Sand is a granular form of silicon dioxide, SiO2, with a small percentage of clay and moisture. And these binders are added to increase the bonding between the sand particles. So, but the basic material will be the sand, which is silicon dioxide, with some percentage of clay and moisture. So, what are the properties of molding sands? So, this molding sand, if you want to select molding sand from different types of sand, we have to consider some factors. So, what are the properties required of molding sand? First one is the refractoriness. So what do you mean by refractoriness? The ability to withstand high temperature without breakdown or fusing. So we will be pouring the molten metal into the sand casting, and its temperature will be very high, above 1500 degree, around that. So the sand must withstand this high temperature, and it will not break down or fuse. And another property is permeability or porosity. The sand must be sufficiently porous to allow the gas and vapors liberated during the casting to escape. So when we are pouring the molten metal, some gas will be producing when it solidifies. So it should be porous enough to allow the passage of this gas and vapors. So that is another property. Then another important property required is cohesiveness. So already you know cohesive strength is the ability of material to stick together. So the sand also must have this property so that it will retain its shape during turnover, removal of pattern, etc. So if it is not that much cohesive, it will be separated, the particles will be separated, and it will be very difficult during these operations. And it should have also very adhesive in nature. So the ability of sand particles to stick onto the other bodies, like molding box, to prevent the falling out. So these two properties are required. Cohesiveness as well as adhesiveness is required for a molding sand. And another property is flowability. The flowability means the ability of a sand to flow to the whole portion of molding box. So it must be flow, like it must behave like a fluid to reach the molding box around pattern. And it should be chemically stable. So the sand must not react chemically with the molten metal. So if it reacts with the molten metal, it will produce some other compounds, and which will come as a defect in the casting produced. So it should not react chemically with the molten metal. and it should be plastic also. It should behave as a plastic, that is plasticity is needed, the ability of sand to retain its shape when the pressure is removed to get a good impression of the pattern. This is very much required. And finally, the sand must be easily available and it must be very cheap. So these are the important properties required by the molding sand. Now let's see what are the important parts of sand casting. So this is a simple figure of a basic sand casting. So you can see here it comes in two parts. The upper part is cope, the lower part is drag. And this is the molding flask. So the wooden box surrounding this molding is known as molding flask. So molding flask is a box that contains this molding cavity. And we have cope. The upper part of the molding flask is known as the cope. And the lower part of the molding flask is known as the drag. And we have pouring basin, a funnel shaped reservoir through which we will be pouring the molten metal, and it helps to maintain the required rate of flow of molten metal into the cavity. So this is known as the pouring basin, a funnel shaped cavity which will help to maintain the required rate of flow of molten metal into the cavity. And what is sprue? The sprue is this vertical passage that passes through the cope and that connects the pouring basin to the gate. So this is the gate here, this is the pouring basin. So this sprue will be a vertical passage connecting these two. And another important part is the gate, the horizontal passage through which the molten metal enters into the mold cavity. This is a mold cavity. So this horizontal passage through which the molten metal enters to the mold cavity is known as gate. And finally we have a riser. This one is known as a riser. The passage made in the cope to permit the molten metal to flow after the mold cavity is filled up. So once this cavity is filled up, the additional molten metal will rise through this riser. And if the molten metal does not appear in the riser, so how will we know that this cavity is completely filled? So we are not able to see what is going on inside. So that's a question. How will we understand this cavity is completely filled by the molten metal? So that is the purpose of riser. So if you look at the riser, if the molten metal does not appear in the riser, it indicates that the mold cavity is not filled up completely. And another function of riser is it also acts as a reservoir to feed the molten metal to compensate for the solidification of shrinkage of casting. So once we know that when a liquid is changed into a solid, its volume will be decreased. So similarly, when we are pouring molten metal to this cavity, but once it solidifies, its volume will decrease, shrinkage will happen. So we have to supply the additional molten metal to fill that shrinkage. So that additional molten metal will be given by this riser. So that is a function of riser. It is have these two functions. One is to understand if that cavity is completely filled by the molten metal, and another function is to provide as a reservoir to supply the additional molten metal during the shrinkage of casting. So these are the basic parts of a sand casting. So you have to draw this figure and mark these parts and explain. And another part is a core. So in this figure you will not see a core. So what is the function of core? Suppose you want a hollow surface inside this casting. So this is a completely solid surface, so no core is required. But if you require a hollow surface or making holes inside the casting, we have to insert a core made of sand, and that is a function of a core. So if you want a hole here, we will insert a core in here so that the molten metal will not gum in that region, so that core can be taken out after it solidifies. So core is used only when we require a hollow surface in this casting. Now we will discuss the molding procedure, the step-by-step molding procedure that has to be followed in every sand casting. So one half of the pattern, so pattern is also made in two halves. So one half of the pattern is placed with this flat surface on a molding board. The drag is placed on the board with the pins downward. So the drag is the bottom up part of the molding flask. Then it is filled with the molding sand and properly rammed. The excess sand above the top level of the drag is removed and level with the top of the drag. Then it is turned over and placed on another board. That is the cope. The other part is the pattern is kept over the cope. So the second part, the second half of the pattern is kept over the cope. And it is placed, just cope is just placed over the drag. The runner and riser pins are placed at appropriate place, and the cope is filled with molding sand and rammed properly. Again, the excess sand above the top level of the cope is removed and leveled. And vent holes are made to ensure the escape of gas. The runner and riser pins are removed and a pouring basin is cut at the top of the sprue. The cope is turned over and kept on a board. The pattern halves are carefully removed from the cope and drag. The gate is prepared on the top surface of the drag. And the core is kept, if it is a hollow surface, the core is kept in position. And now the cope is kept carefully in position on the drag and clamped. The molten metal obtained from the furnace is poured into the mold through the pouring basin. And after allowing sufficient time for solidification, the casting is taken out by breaking the mold. The unwanted projections on the casting due to runner and riser etc. can be removed, cutting them off. And finally the casting is cleaned and grinded for a good surface finish. So this is a general procedure to prepare a molding cavity or a casting. Now we are in the YouTube, we have several animations that will be helpful to understand casting. So this is a sand casting animations. So these are the two parts of the molding flask. So this is the part to be cast, some impeller. So we are placing the molding flask. Patterns are made in these two halves. The sand is filled and rammed, compressed it. So this is drag, this is cope, and it will be made upside down. And this cope is placed over the drag and the pin is attached. And after that we will pour the molten metal from a furnace. And it will solidify up and pull. The pin is removed, the casting is taken out, and this riser and runner passages can be cut, and like this we have obtained a casting. So this is a simple animation to understand about casting. Now this is an
with a
actual
pattern of
procedure.
a
It's also
slingshot
from
and some
YouTube
proper molding sand for green
to
sand casting.
make a
You can watch
casting
how I
of
made
this
this
shape.
pattern in one
This
of my other
aluminum
videos.
shaped metal parts
The
is
link
to
will
be
be in the description.
produced.
There will also be a link to a video where I show how to cast the
So what is the
aluminium
procedure
slingshot
to produce a
without the
part
need for
like
woodworking
this?
equipment for making the pattern.
So this is a
I got the
pattern.
molding
So
sand of
it's
eBay.
made in two
It is
halves,
not
two equal
expensive.
halves. It's
To make the
made
mold,
of
one
wood.
half of the pattern is laid face down into the
So this is a
flask.
molding flask.
I apply a bit of talcum powder to prevent the pattern from
So
sticking
it's
to the
made
mold.
upside down
Then the
first.
flask is completely packed with sand.
And first the one half of the pattern is placed to prepare the drag. And now we can fill the molding sand like this.
And the excess is then
And once
scraped
it
away.
is completely filled, we can remove the excess sand. So this is how we have prepared the drag, the bottom part of the molding.
I had to repair the areas around the fork tips because the pattern had moved slightly.
Now we can place the cope just over the drag, and we can place the other half of the pattern to match this like this. And the same procedure is repeated. Again we have to fill the sand. So before this the pouring basin. So in this is used as a pouring basin, this flask.
Now the second half of the mold can be made in
So it
similar
is placed
fashion.
in the
Only
place.
that I added a silicone cartridge to form the sprue for pouring in the molten metal.
And we will again fill the sand, and we can remove that pouring basin flask. So again, once again we have to take this out because to cut the gate, sprue, runner, etc. So the cope is taken out. And the patterns are removed from both the cope and drag. And this is the vent hole. So we have to provide some vent
Now
holes
the mold can be opened and
for
the
the
pattern
escape
can
of the
be
gas.
removed.
Tiny holes. And this is the gate. So we are cutting a gate. And now our cope can be placed above the drag finally, once again, and the pins are fixed to clamp this cope and drag. And so we require a furnace to melt the metal. We require a furnace, that is a must
Vent
for any
holes are poked
casting.
at the high spots of the cavity
So it's
for the
aluminum
air to
furnace.
escape out of the mold.
And it is poured into this pouring basin in the liquid form, and some time is
A tunnel is created to connect the sprue to the cavity.
for cooling, and we can remove this cope. So this is the shape of this is obtained, but we have to cut this excess part. This cavity shows the pouring basin where the molten metal solidified. So this gate passage, all these are to be removed.
The mold is closed and now
So
ready
we
for
have taken
pouring.
out the casting, and we have removed this excess part by grinding, and finally we can show the final surface finish and cleaning, etc. So this is how we are obtained the aluminum casting step by step.
Aluminium was molten in a coal fire and then poured into the mold. Clamps guarantee that the mold won't open and let the aluminium spill out. I was really surprised how well it turned out. The surface of the casting is really nice, almost acceptable for a slingshot. The molding sand can be reused several times. If I had a buffing wheel, I could polish this up to mirror finish, but I really didn't want to take the time to do it by hand. So that's what it is. I hope you liked it.
So next we will see what are the advantages of sand casting compared to other techniques of manufacturing. So first advantage is larger parts may be obtained. So we can cast a very large engine or very large pump etc. through this method. And similarly we can cast small parts of complex shape also with the sand casting. That's another advantage. And a wide variety of metals and alloys can be cast. We can cast aluminum, iron, so many metals and alloys we can cast. And external as well as internal shapes can be created. So we have seen the hollow shapes we can create with the help of a core. That is another advantage. And disadvantage is its dimension accuracy is not that much great. It's a poor dimensional accuracy. And surface finish also is less, so we have to grind the casting once it is obtained. And another important disadvantage is we have several casting defects like porosity. So porosity is a casting defect in which number of pores are obtained in the product. Similarly, misrun is another casting defect, so that the molten metal will not reach the entire part. So cold shed, so many casting defects are there. So there is a chance that these defects will be in the product. And another disadvantage is there will be safety issues. So we are dealing with the furnace and heating of molten metal. So we have to take care of the safety of the workers. And another disadvantage is the material obtained will be not that much of good strength. Strength will be poor. Now where we are finally going to apply this sand casting method, we have several applications for sand casting. So below are a few of the applications. The engine block. So the engine block, this is a figure of engine block, a 8-cylinder V engine. So this engines, large engines can be easily cast with the help of sand casting. Similarly, we can cast a gear. So already we have studied the working of gear. So we can make a gear, large gears with the help of casting. And also we have studied the pulleys, the use of pulleys in belt transmission. So a pulleys like this can be easily made with the help of sand casting, and we can produce several pipe fittings, valves, etc. with the help of sand casting. And similarly we can produce the pump casing, the casing of a centrifugal pump or similar pumps by casting. And we are told in ancient times itself we are used casting to produce different sculptures like this. So these are a few applications of sand casting. So with this we are stopping this session. So we will continue with another manufacturing process.